Let's go to page 313, and this is section 26.2. This section is on the probability. So probability is the likelihood of some event happen, and probability most of the time is not too bad if you know how to count correctly. Okay. And the definition of the probability of an event happening, so that's called it A. A is the event description of the event. So probability of an event happening is equal to the event, the number of ways it can happen over the sample space, okay, the sample space is the total number of ways it can happen. Okay. And so let's go and go to example on page 314. Let's go to example 26-4. Okay, so this problem, it says if a box, so you have a box, and contains 2 yellow and 1 red. So what is the probability of drawing out the red one if one ball is drawing at random? So you're looking for probability of 1 red. Okay. So probability of 1 red, again, event is 1 red. So there are 1 here. So the only way you can draw it, there's only 1 way. Okay. There's 1 red. And sample space is the total, so there are total of 3. And so that's your probability. So probability of getting a red is 1/3. Okay, now let's go to example 26-5. It says if a box contains 2 yellow and 1 red one, what is the probability of drawing a red and a yellow if 2 balls are drawn are drawn? Okay, so probability of 1 red, 1 yellow. Okay, now when you're drawing more than 1 item at a time, then you need to use a combination. Okay, use a C. Okay, so to red one, so there's 1 red one, and you want to get 1 red one. There are 2 yellow, and you're going to get 1. So again, you're going to get 1 C1 for the red, 2 C1 for the yellow. Okay, so that's even. Again, you want to get 1 red one. So this is a total number of red, and that's how many you want. Total number yellow, that's how many you want. Divide by the sample space, the total. Okay, the total there are total of 3, and you want to get 2 at a time. Okay, again, this is the overall, and this is specific to the what you want. Okay, so you want to get red and yellow would be, so this would be 1, this would be 2. Okay, and then the 3C2 would be 2, 1, 3, 2, and would be 3. Okay, and so the probability of getting a red and yellow would be 2/3. Okay, let's go to the next example. Okay, example 26-6. It says John and Jen each choose a number not necessarily different from 1 to 10 inclusive. Inclusive means you include those numbers. So they're going to get a number randomly. What's the probability that each pick a number greater than? So you want to get number greater than 7. Okay, so that means you're looking for 8, 9, and 10. So probability would be equal to, now to do each individual person, right? Okay, so for John, to get that would be, again, event. You want an 8, 9, or 10, so there are three choices. Over the sample space, the total would be 10. So this is for John. Okay, and you have to get Jen, same thing, 3/10. Again, because remember the definition, event is what you want, sample space is the total. Okay, so again, this is what you want, and this is the total. So what you want is 3, there are 3 choices, and total, there are 10 choices. Okay. And therefore, probability of both of them get greater than 7 would be 9/100. Okay. Okay, let's go to example 26-7. Says, what's the probability of 5 cards poker and contains exactly 2 aces? Okay, so you have 5 cards. Now, when you're doing the cards, you have to make sure everyone is accounted for. So you want to get 2 aces. Okay, and you're going to make sure that you count for all 5 cards and 3 other cards. Okay, so others other than the aces. Okay, so probability would be equal to, so you have to kind of, again, event. It's what you want. So you want to have 2 aces. So you're going to get 4C2 because there are 4 aces in the deck and you want to get 2. Okay? Then others. So there are 48 other cards and you want to get 3. Okay? So again, these are aces. There are 4 aces, you want to get 2. And there are 48 other cards that you want to get 3 out of that. And over the total, there are total of 52 cards and you want to get total of 5. Then after that, you can go and simplify, you can calculate these. Okay. And the number obviously is going to be kind of, this one will be kind of big. Okay. So that means your answer is going to be kind of small decimal. Okay, let's go to the next one. Okay, so it says, let's examine a more complicated probability problem. What is probability that a 5-card poker, again, so you're going to get 5 cards, have exactly 2 cards of the same value. So it means you're going to get a pair. So you're going to get 1 pair. Okay. And no other cards duplicated. Okay, so it can mean 1 pair. Because other card duplicated means you're going to get like 2 pairs or like 3 of a kind or things, yeah, right? Okay, so you want to get 1 pair. Okay, so first you need to do is, so probability would be equal to, so to get 1 pair, first there are 13 ranks, like, like ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of those are called ranks. So you have to choose what rank you want to get for the pair. Okay, so there are 13 ranks. You want to choose 1 rank to get a pair. Now, after you choose a rank, okay, there are 4 cards in each rank, right? There's a club, spade, and then heart and diamond, right? So there are 4 cards in each rank, and you're going to get 1 pair, so you have to choose 2. Okay. So you want to get 1 pair. That means you're going to get 3 other. So make sure you account for all the cards. Okay. Okay, now to get the other cards, first you have to choose a rank. Now because the 3 cards, so you choose 1 rank, right? So it means you got 12 ranks left over. So out of those 12 ranks, you're going to choose 3, okay? Because all 3 cards have to be different ranks, or else they're going to end up with a different pair, right? So you have to choose 3 different ranks, okay? So after you choose each rank, okay, then you have to, so for 3 cards, the first one, the rank that you choose, there are 4 cards in that rank, you have to choose 1 of them, right? And the second card, again, there are 4 ranks, you have to choose 1 of them. And the third card, again, there's 4 in the rank, you have to choose 1 of them. And then after you have to divide the total, right? The sample space would be, there are total 52 cards, and you have to choose 5, okay? Okay, so you can sum up, okay, so to get a 1 pair, there are 13 ranks. So you have to choose 1 of the rank to get the pair. Now after you choose a rank, in that rank, there are 4 cards in that rank, okay? And then from the 4 cards in that rank, you choose 2 to get a pair. Then you have to take care of the 3 other cards, okay? Now remember, there are no duplications, right? So you cannot get another pair. So therefore, there are 12 ranks left over. Of the 12 ranks, you have to choose 3 ranks for each one of those cards. Okay, so after you choose the 3 ranks, then the first one in that rank, you got 4 cards in that rank, and you get 1. Okay. The second other card, again, after you choose a rank from here, within that rank you got 4 cards, right? Because again, you got the heart, you got a diamond, you got a spade, and you got a club, right? So out of that 4 cards in that rank, you're going to choose one. And do the same for the third card. So you get all this and you divide by the sample space, and that's how you figure out the probability. Okay. So to just a little bit of review how to do this. Okay, so 13 choosing 1 would be 13, 1. Okay, 4 choosing 2 would be 2, 1, and it would be 4, 3, right? And this one over here, the 12 choosing 3, okay, you're going to get 3, 2, 1. Right? Again, the lower number give you the factorial on the bottom, and the top would be just follow whatever, how many numbers you have, starting with the higher number. So there are 3 numbers down here, so you're going to get 3 numbers up here. Okay, and this one, 4, 1 would be just 4 over 1. Okay, 4 over 1, and 4 over 1. And 52 choosing 5 will give you 5, 4, 3, 2, 1, and then this would be 52, 51, 50, 49, and 48. Okay. Now, many of the calculator has the features to that you can calculate. Some of them have the NCR, and some of them have the. So you kind of have to look at calculators. Some don't. If some don't, then you can use a factorial. Okay. So if you have a scientific calculator, they have the button that says it says NCR, the button. So you can use that button to do each one of these. Then you don't want to do all these. Okay, so you can just use that to figure each of these, and you multiply and you divide by that. Okay.